Hello and welcome back. Today we are going to try to attach the leap motion to this process. So one thing we should do, let's just go ahead and run the app, see where we are. I will note that I did download 2 sounds from Free Sounds to change out the sounds that I had, something that will work a little better, I think. Use whatever sounds you want, obviously. Okay, so this is where we are. And I have a couple new, the sounds in 3 and 4 have been replaced. Okay, so one issue we have, the leap motion's working. The GUI, or my display, is blocking what the hands are doing. So I'm going to make a toggle, just going to be using the H button, the H key, and have a toggle so I can turn that GUI on and off. So let's make this is part of the GUI really, so let's put it here. Display GUI. And in the setup, let's go ahead and set that to true. And then in our draw loop, wherever we draw this GUI, we will only do that if display GUI is true. Alright, so this whole section. If display GUI Alright, so that should still draw it, and then come down to key pressed. If key equal to the ASCII H, so putting it in single quotes will report the ASCII value, which is an integer. Display GUI equals the opposite of display GUI. Okay, so let's make sure that, whoa, nope. It is unhappy. Oh, okay, so I've spelled it wrong every time. That's always fun. Display. Okay, and make sure this one's correct. Give that a run and make sure we can hide the GUI. Okay, so I can hide the GUI. And bring it back. So, I'm actually going to start amplitude lower, so every time I run this we don't get assaulted with sound. And, yeah, that would be nice. Amplitude, we'll just start it low. Okay. So we have a way to hide the GUI. So now what we need to do is find a reasonable range for the XYZ positions of the hands. We want to clamp that. So we'll have to write a function to find our leftmost bound, our rightmost bound, our depth bounds, and our height bounds. So what I'm going to do to accomplish this is keep track of for each hand, keep track of the minimum location and the maximum location. And print that out so I can scroll through and print out that function. Yeah, so let's go ahead and get started here. Here is the leap code. We can see what's going on here. So we want to find, I think these inherit from openFrameworks node, if I'm not mistaken. Or they're points. Okay, so these are the points of the fingertip, distal, proximal, metacarpal. My anatomy is not great here. Let's see. If leap frame is new and simple hands dot size. So if this is non-zero, so if there are hands, set mapping here. I'm not sure what that's doing. So for each hand, I'm going to assume the metacarpal. You know what? Google is our friend. So, oh, sorry. Metacarpal. I don't need to know about the fracture. Okay, so right, so the base of the metacarpal is our hand. So let's go ahead and run this again. Let's go to the draw and let's make sure we're tracking. I just want to track the center hand position. So when it draws the center hand position, oh, okay, never mind. This is simple. Hand position is a vector. A vector is primarily it's just storage for an XYZ location. It also has a lot of handy functions. You can do various vector math with that easily. But we can also just call hand position. So we can just keep that here. So we have an array of hands, which a simple hand is a data type that this library has. And we have an array of those. You can have as many hands as you want. We're assuming 2. So simple hands 0 and simple hands 1. So one thing we might have an issue with is it seems to be agnostic about whether it's left or right hand. So we could write a function to determine. That would be the slick way to do this. There's a way of knowing just based on the orientation of the fingers which hand is which. I'm just going to make this easy on myself and always put my left hand in the sensor first. That way that's hand 0, and then put my right hand, and that'll be hand 1. And that's, since I'm writing this for myself to perform, that's acceptable. If you were making a synth for someone else, you'd want to make this fail proof and not alternate hands. Okay, so simple hand 0 will always be the left hand. So let's just do a quick test. Kind of don't want any of this to print. I'm not sure how to stop that at the moment. Let's see if the author has said anything. Okay, let's not set this on verbose. And let's see if that it should get rid of all these verbose couts. Okay, and then actually let's just verify that, because I want to log the positions, and it's going to be a pain if it keeps giving us all of these frames. Okay, and we can also get rid of our number active collection. We don't really need that anymore. So I'm going to Command F, cout. I forget where I wrote that. Here we go. I'm going to comment it out in case I want it later. All right, so now our console log should be fairly clear. All right, so simple hands is here. Leap.get simple hands is returning a vector, presumably, of hands. So let's just do a cout simple hands at 0.x in line. Simple hands dot position dot x. Let's see what it wants. Okay. So I'm going to come back 0 dot and see what it gets. Hand pause, that's right. And that's a point, it's not a vector. So a point is just the storage. I think that's the difference between a vector and a point, is that point has a position. It doesn't have all the methods that a vector has. Either way, it works for us. Hand pause dot x. So we're just getting the x position of the first hand. All right, so if I'm not mistaken, trying to do this will crash the program if there aren't any hands. We could verify, but this seems like it's going to happen. So we can make a check if simple hands dot size. So if this is greater than 0 or non-zero, it would be probably more clear. Greater than 0. There we go. If there is a hand, print that hand's x position. And that's also be a little clear here. Hand x. Okay, so I'm going to screw this over. I'm going to put my left hand over, and we are getting, presumably, the x position. I'll move my hand to the right, it's higher. Move my hand to the left, it's lower. So one thing I want to do, I want the left hand to occupy the left half of the space and never really go over to the right side. And the right hand to occupy the right part of the space and never go over to the left side. So that will make this easier. I don't have to worry about occlusion. If you put your hands on top of each other, sometimes, like my right hand's on top of my left hand making a fist. Obviously, the leap motion can't see that at all. I open my hand and it might come back. There it is. All right, so I don't want to have to worry about any occlusion here if my hands cross each other. But, so you can see, I mentioned getting, yeah, so let's go ahead and print. Let's make this easy on ourselves. We could, there's a number of ways we could do this. I think the best way, the most time efficient way will just be to temporarily make a variable. Let's put this in loop stuff. This is temp, delete this. Okay, so we have a float, and we'll call this lowest x. And then we'll also have, we know that the center will be 0, so we don't need to store the highest x. Let's store the lowest y, the highest y, lowest z, and the highest z. All right, so we're going to keep track of the lowest and the highest. We have to put this here because we have to store this outside of this loop. Okay, so if hands are greater than 0, that we confirm that this worked. So this will be the function here. So if simple hands at 0 dot hand position dot x is lower than lowest x, lowest x equals the value here. So only print it if it was lower than a previous value. Okay, well, it only store it if it's the lowest value. So we want to do this for each of those variables. If, oh man. 2, 3, 4, 5. I think we had 5 of those. Hand position y, lowest y, lowest y, if y is greater than highest y, highest y equal so if it's greater than the previous highest, our highest value is that highest. So let's do the same thing, z, lowest z, okay, so now we'll want to log all of these with a long cout message. All right, cout lowest x equals lowest x. All right, notice I didn't put an end line there. I'm going to put an end line after the last one. Lowest y equals highest y whoa. Okay. And then we'll also, at the very last one, end line. So these should print out every time. I'll move my hands through what I think should be the full range of this instrument, and then we can check the last log in the console, and that will give us our cap values here. And I'm going to go ahead and assume that whatever these lowest values are and highest values are will be the same with both hands, since it is symmetrical. Nope, stop. Let's get rid of this. Oh, whoa, I want to... Okay. I want to restart. I reached over to turn the... I'm right-handed, and I'm testing this with my left hand. My natural instinct was to reach my right hand into this. So I'm going to start it again and use some synths here. All right, so I'm bringing my left hand in. I'm bringing it as far forward as I would want in this to use in the synth. As far back as I would want to use. Note we don't have an X. Let's bring it as high up as I would want to use, and as far down as I would want to use. And let's bring it as far left as I would want to use. So now it should store these values, and we can check the log. Alright, so I'm just going to grab this. There's not enough room in that log there. I'm just going to, let's see. There we go. Great, so this is fairly straightforward. That's good. And I haven't read too deep into the Leap Motion library. There might actually be methods to just take care of this. It looks like there was something in place, the set mapping function, but however, this is what we're going to do. All right, so we have these values. I shouldn't need this anymore. So now what we want to do is map the values we're getting here. So there's some stuff going on here that we really just don't need for our. I mean, I'm going to leave the visual in there. It's good to see where your hands are when we're performing, and I don't see any reason to reinvent that wheel. Simple hands is instantiated here. I'm going to go after all of this. Copy and paste it here. Okay, so I think what would be safe is only to update these values when there's two hands. For now, I won't worry about that, but I'm afraid something bad would happen. And it'd be good to put a safety check. So it only controls the synth when both your hands are present. That will prevent any accidents when you're reaching across the leap motion with one hand, for example. However, let's just keep moving. So we have these values. And I believe on the slider, let's just verify, that you can set the slider position by just making this word equal to something, this variable equal to something. So let's check that. What would be good for that? See, let's just randomly assign the X location just to verify that that's how that works. So X location, the name of the slider, equals of random 1.0. And I don't need to put a second value since it's by default 0 to 1 here. And that should happen every frame. So we should see the X location on the slider jumping around randomly if this is true. Oh, there it goes. Oh, ha. Right, so it's only going to do that with my hand there, because I still have that function. But yeah, so we can use the same variables. We don't have to make new variables. And also we'll get a visual with the slider of what's happening. So X location will now equal, let's see, lowest X is negative 600, so X location equals of map, simple hands at 0, oh well, not O, dot hand pause dot X. So we're mapping the X position of the hand from the leap from negative 600 to 0 to 1. And of map does have a clamping function built in. So I believe if I put true at the end, we're fine. And it's a Boolean. It's by default false. But if I say true, it won't let it go outside the range of 0 to 1, which is what we want. So let's see if we can now control the X position with our X position of our left hand. Cool. All right, so this is fairly straightforward from here, right? So Y location equals of map, simple hands at 0, hand pause dot Y, and we can look up at our highest and lowest input values, which is negative 380 to 363 and 0.0 to 1.0. And also make this clamp. All right, bring my hand in. Ah, okay, one issue. The Y position isn't 0 to 1, it's 0 to 3. So let's go ahead and fix that. a Y location, the slider. Cool. Note the inversion. The Y is inverted here, so let's go ahead. Fortunately, it's easy to fix. We can just switch this 3 and 0, and we'll be set there. So now it will map directly. Currently, there's not any. It would be nice to leave the GUI and have it transparent. My sound file drawing, I don't think, has the option to change the color to a transparent color, so I'm not worried about that at the moment. But it'd be nice to be able to see the hand and the position at the same time. That's something I might add to the library, because clearly it would be useful. And note when the hand is no longer discoverable. It disappears and it doesn't crash because we did that safety check. Okay, and we are going to attach Z to reverb. So let's do that. What did I call? I think the reverb. It's the slider is called reverb. So reverb equals of map and the lowest and highest is -166. Uh-oh. Oh boy. All right, so these are the same value. I must have made a mistake here. Yes, that should be a greater than. Let's give it a run real quick and see what that value would be. Presumably, it's the, just a positive 166, but... Oh, I should probably... I'll just go ahead and finish it with that assumption in mind. And 0.0 to 1.0 and clamp. It's called reverb mix. Let's go up and find out. Reverb feed. Okay. And let's see what that number actually is. The highest Z was 254. And also let's, I'd like, the further away my hand is, the more reverb I'm applying. It's a little poetic, if my hand's further deep, the deeper reverb. Yeah, such poetry. Okay, so another thing we want with the left hand is open and close, but let's get to that in a little bit. Let's do the right hand quickly. So the right hand has amplitude on the y-axis. So amplitude is the name of the slider. Is of map simple hands at 1 hand position dot x, and I'm going to assume it's 0 to 600 since the other one is -600 to 0. And this will be 0.0 Oh, no, sorry. This should be the same. So it's negative 380 since this is I'm starting with y, that was the issue. Negative 380 to 363, 0.0 to 1.0. Now let's go ahead and reverse it because we know it will be reversed. 0. And clamp it. And I'm confident with that, so let's just do the rest of these. The x-axis is emission rate, so emission simple hands 1.x 0 to 600, and we'll map that from was I think a 0.1 to, was it 1,000? Yes. And clamp it. And then Z was duration. So duration equals of map simple hands 1 dot hand pos dot Z. Yeah, the values are likely the same. Negative 166 to 254. And duration was, I think, 0.1 to 200. And clamp it. All right, so one other thing we need to take care of is we might be accessing a hand that's not there. And actually, we definitely will be at the very beginning, and that will crash likely. So if the hands dot size greater than 1, so if there are 2 hands or more, we'll take the first 2 hands and use this value. Okay, that worked fairly well for just beginning. The hand location, or the openness and closeness of the hand hasn't been set yet. So let's consider this. There's no, to my knowledge, there's no built-in function to find how open or how close the hands are. What we have to do, or what I've done before, and I think is simple and effective, is to just measure the distance from the tip of the thumb to the tip of the index finger, and just use that distance. So it's more of a pinch, and you know you can open and close your hand above the leap, and that will still be true. Your thumb will be close to your index finger if your hand's closed, but you can also treat it like a like you see people playing a theremin. They always have their fingers pinched, and we could use it like that. So just, you know, openness and closeness of the thumb to the index finger. So let's actually. Do we need to store that value? No, we don't. So for every hand, for every finger, so we can get F. So I wonder which hand is which. So let's just start with the assumption that finger 0 is the thumb, finger 1 is the index finger. Okay, and then this information is stored still. So what I'm going to do, come out of this. Oh no, I'll leave this in. And do I just want to find this hint. Yes, okay, so we can get the distance there. There's a function for that. It's just Pythagorean theorem. But all right, so float distance equals of dist simple. This would be long. Hands 0 dot hand. Let's see. How do they store these? Dot fingers, not hand. Dot fingers. Dot fingers at 0. So hand 0, finger 0. Dot. Oh, that's a lot. MC fingertip is TIP, and yeah, that's storing a point. Where is this being put? Where's ID? Simple hands at fingers. Okay. I think this will return dot x. Is that going to let us do that? Oh, there's an array called finger types. Finger type 0 dot x still. A little confused at what this wants. Let's see what if this is actually helpful. Does not refer to a value. Of course it doesn't. I didn't want it to. Okay, finger types. So we'll have to do that. If this is doing what I think it's doing, we'll have to do that 3 times. It's a lot to write, but the computer doesn't have any more trouble accessing that variable. It's just cumbersome to write. Y, Z, X, Y, Z, and these will all be finger 2, or the second finger. And then a colon. Oh, there's a lot of issues. Okay, so, oh, where did we go? All right, so finger types is used up here. Am I not allowed to use that for some reason? Ah, that's instantiated here. Okay, so we don't need to reinstantiate it. So let's go. This is a long function. It's just a distance calculation, xyz to the distance of another set of xyz. Let's cut that. We can do this in here. So now we have access to finger types. Okay, cool. So the issue now that we'll have is that distance is being instantiated inside this local for loop. We can get out of that by doing that. And let's actually just call this distance 1. And we'll declare that variable out here, distance 1. So that's a little obnoxious, but I think this will work. Let's print that to the console. Cout distance thumb and index and 1. see if we're getting anything reasonable. So I'm going to try to move this over here, and so yep, okay, so the lowest distance we're getting is around, I'm going to call it 30 and clamp it at 30. And when I open my thumb and index finger all the way, the highest we can get is 250. So 30 and 250 is our range. So we guessed right when we're saying that the finger type is at 0 is the thumb, finger types at 1 is the index finger. Okay, so 30 and 250 is our range. So we could actually just set that here. And I'm going to just instantiate this as 0. Or I guess since 25 is our lowest, we can do 25. And then we can set left open, the slider name, equal to of map distance 1, 25 to 250 to I think I did normal, so 0 to 1, and then we'll clamp that value. So let's see if that works. Okay, it seems to work. And so we can, I'm assuming the distance will be the same. So float distance 2 equals 25. I'm just going to copy all of this. And note that this isn't in our only if there's 2 hands decider here. But that's fine. It has its own safety check at the top. So simple hands. So hand 2. Hand 2. All right, I think I have that all correct. The fingers remain the same, but the hands are different. Okay. And so right open. All right, so let's give this a go. Oh wait, one more thing I want to adjust. The amplitude is reversed, what I would think is logical. When your hand's high, it's quiet. When your hand's low, it's loud. So let's flip that amplitude. I flipped it, and I guess I shouldn't have. Huh, that's new. Ah, okay. Like I said, but I was wrong. Is that there is a check? Here we are. Here, and that check is different than our check. So this will, this is doing this all for every hand. But if there's only one hand, that means this hand doesn't exist yet, and it will be no access to that memory. So the reason we put this up here in the first place, well, we could, trying to think of the best way to handle this. One issue is that we're doing this all twice. So finger type is this array. Oh, yeah, we could have checked here. So 0 is thumb, 1 is index. I should have looked at that. Here we are. Oh, and also this would be distance 2. Okay, so thinking here, we can put this out here. There's no reason to keep that out. Everything still has access to it. And let's move this to our safety function. So if there are two hands, that still looks happy, so we should be in better shape now. Okay, the right hand is not... The left hand is controlling both left open and... Oh, here is Y. Distance 2. Alright, so this is definitely going to take some practice. No, if I move one hand out, my hand will switch position. So if I move my right hand out and back in, we're good. So I can move my hand all the way down and we can hear the reverb tail. My reverb value doesn't seem to be adjusted. Oh, okay, it's right hand, sorry. Yeah, so it'll definitely take a little bit of practice to get right. Okay, that's promising so far. I wonder, we had some clicks and pops. Oh man, and a lot of calls here, so it's gonna be hard to find out why. I'm wondering if we had an audio thread malfunction, or if it was the hand coming in and out and changing a variable all of a sudden. It might be a good idea to add smooth values to all of these, or all that wouldn't be incredibly computationally efficient to add. That way, if it does come in and suddenly it won't just jump to a position, it will slide there within, you say, 100 milliseconds or something. So you wouldn't get that kind of sudden change if a hand falls out. Another thing I'd like to change is making it a little easier, the range a little smaller. I mean, I'm sitting at a crowded desk at the moment, so it's a little hard to navigate with them. Try not to punch the microphone, that sort of thing. Hopefully, with a performance space, it'll be a little bit easier. But the idea is it won't take too much practice time, and I can fill in sounds that we can get rich sonic results. Let's see, what can we do quickly? So instead of the X ending at 0, I think it should end at -20 and 20, for example. So where is all of that? Up here. Okay, so X from 0 to 60, let's do that 20 to 60. And X up here, -60 to -20. That way, if I want both hands to be in the center, there's actually room for them to be in the center at the same spot. So the center for the left hand will be a little bit to the left, and the center for the right hand will be a little to the right. Also, I might tame in those values. So we found the maximum and minimum, but the maximum Y value might be different depending on where the X value is. It just depends. If you've used Elite Motion, it kind of is, there's a cone basically that comes straight up. So if your X is way out to the right and you come straight down, you're out of the line of sight. So I'll have to account for that in some way. Hopefully not too tedious of a way. But yeah, so this is, I'll probably practice this a little bit and add a little clip to the end, or maybe to the beginning, just to show what's actually being built. But I would call this, 90% done, 95% done. So it's just a little bit of fine tuning and practicing and selecting sound files, I think, at this point. So this is the first time recording a video in this format. Let me know what you think. It's definitely going to be a really long video. It was a really long process. I plan on doing at least one more video like this. The next will be a wave terrain synth, MIDI controlled. So if you do like this format and like seeing projects completed from beginning to end, let me know, and I will try my best to continue and do these sorts of things. And I will definitely be continuing ofxATK tutorials, focusing on more specific aspects of the library and how to use it. So with that being said, thank you for joining me, and hope to see you next time.